That's funny. It just says progress, not recording in progress. All right. So I just wanted to make sure that I don't think I said this clear enough previously, but your exams are all curved prior to them going into gradebook. So if you go and review your scores now online, there is a section on the D12 gradebook that I wrote on there called curved exams or curved exam scores or something like that. That's the actual score I'm going to be using. All right, I just call it exam 1, exam 2, exam 3, exam 4, exam 5. Does that make sense? All right. The curve might change slightly. I haven't 100% decided on what the curve is going to be for all the exams yet, but there will be curve. All right. Any question?
I'm doing 1, B2, the homework, and I'm doing good. I'm doing really good on it. I only messed up one time on one question.
Well, that's all. We haven't even gone through that yet, so we're going to go through that today. Question?
Any of the questions are on the test?
No. The reason being is this though. For this particular class, the way it's set up, it goes sets, logic, geometry, probability and counting, and then statistics. Each individual test has virtually nothing to do with the next one. So like if you did poorly on it, it's not going to really affect how you will or won't do on the next exam. And then the other thing is that I was mentioning this previously. I'm not sure if you were here when I was saying it, but when I do go over it with students, it ends up being mostly reading errors that the students are making, or they forgot what some of the symbols meant. Not necessarily that if they understood it and were able to read it correctly, that they wouldn't be able to do it. It's a lot of bad mistakes. That's what I find usually. Send me an email. Oh, okay. That's not a problem. So like the maybe it's wrong, maybe it's graded incorrectly. You know, I'll go look, I'll see. Then I'll look at it. Don't worry about it. I'll look at it. I unfortunately don't make the exams for this class, so I can't say. But I can certainly take a look at it, and if the stupid thing's wrong, you know, I could deal with it. All right. All right. What are we doing? All right, so let's do this stuff.
As far as the homework, when is it due?
Whatever it says on my math lab, I don't know what the dates are, unfortunately, without looking. Yeah, it shouldn't be due today. Should be due by like the next class meeting or something like that, or next week or something. Because we haven't gone over it yet. I don't like to make things due until we go over it. All right. So, all right. So this chapter is about logic. The stuff about sets. The stuff about sets actually has like there's a lot of relationship between the way you do things with the sets and the way you do things with logic. So that's one thing that's actually kind of good about this. But as I said before, if you haven't learned sets at all, doesn't really affect how well you'll be able to do this. Does that make sense?
Catchphrase. Does that make sense?
That's my it's actually bad how often I say that shit. So when they come and they do the observations, they're like, you gotta stop saying that. I'm like, yeah, honestly I can't at this point. Yeah. At the high school I teach at, the kids made me a stupid button. I wear the same shirt all the time, right? So they took a picture. So I sit there, I'm like this, right? I take a picture, and then they took a picture of me and they put it on this button, and it says on there, does it make sense? Something like that. Does that make sense? I don't. Anyway, so they wrote that. I'll go get the button. I'll bring it. So then so they wrote down the button, and they sell it around the school. They made a lot of money. All these, so then these kids come in and they're supposed to wear these IDs.
Mhm.
And the kid comes in with that button on. And it's nobody notices they're not even wearing the stupid ID, that there are pictures on it.
That's funny.
There actually was kind of funny. All right, so symbolic logic uses letters to represent statements and symbols to represent connectives. Truth value is either true or false. We'll assume any statement is either true or false. Now you got to be careful with this a little bit. I don't care what you think about whether or not it's true or false. It just matters if the question, the way it's stated, the statement is true or false. Okay. Like, I don't care how much money you have or don't have. If it sits there and they say, like, the person has a lot of money, they're not necessarily talking about you. You get what I mean? So like, you can't impart like your own thinking to these statements. It just has to be the statement by itself, it's either true or it's false. Does that make sense?
Mhm.
Once we know it's not false, it automatically has to be true. Once we know it's not true, it automatically has to be false, etc. Does that make sense? All right. It gets a little annoying sometimes where like we start putting what we think into the question and then it becomes wrong then. All right. You'll see though. Compound statement, a new statement formed by combining two or more statements with a connective. Like I remember when I took English, like they would talk about like independent clauses and dependent clauses and all this stuff. And then like when you put like and in the statement, it joins two independent clauses. Like I went to the park and I went to the beach or something like that. It's like two sentences, right? Same thing here. Does that make sense? All right. Then compound statements, the statements which make up a compound or component statements, excuse me. The statements would make up a compound statement. So like the individual parts, those two statements, those two independent clauses, they're each one they're referring to as a component or component. Connectives and or not if then, we'll talk all about this stuff a lot. Negation is just another way to say not. Is that correct? Right? Changing the words of a statement in order to change the truth value, right? All right, so now it says decide whether the following is a statement or it is not a statement. So the only thing they said really at the beginning was whether or not, like, to define these things as statements in this book, I guess they're saying that it must only be either true or false. Does that make sense? But not both. Does that make sense? Now, in other settings, you can actually be both true and false. You can be neither true nor false. That gets more complicated. We don't have to do that crap. I don't even want to mention it, honestly. But there is more to this, is my point. Does that make sense? All right. Oh, why is this at all useful? So, for instance, I had to learn this and sets when I was in middle school. And the reason why they gave it to us was because they thought we weren't going to be able to do algebra. And they were right. And but I got to tell you, there were all these kids in my class that couldn't do algebra at all. And they liked this stuff though, because it's analyzing sentences. It has to do with how you read a contract or something like that, right? And believe it or not, the stuff's on the LSATs, stuff you need to go to a law school, all right? Because a contract has to be coherently written and has to make sense from line to line. If there's one flaw anywhere through the entire thing, then all of a sudden the contract's void, right? So you need to make sure that the contract is written correctly. And then not only that, when you're reading or signing a contract, you need to be able to read it and make sure you know what it's trying to imply or what you're signing, right? So this stuff has a lot of fairly reasonable uses, okay? Also, if you see lawyers, when they go and they start interrogating the person on the witness stand or anything like that, like what they do to this person, they ask the same question 5 different ways to try and trip you up, right? Okay, they say the exact same statement in such strange words that even when you know what the answer is, now all of a sudden you're confused and you might say something else. Does that make sense? You'll see politicians constantly do this when they're giving speeches. Constantly. All right. Sometimes people add things into sentences or paragraphs just to sound smart. But it's not necessary at all. This stuff helps you identify those things. Okay. So there's also, when I was a kid, they had this game we used to play, math game. But it was called Knights and Knaves. The knight always tells the truth, the knave always lies. And they would give you a series of statements by these people, and they would make these statements, and you had to figure out which one was the knight and which one was the knave. This allows you to determine if people are lying. Does that make sense? All right, so June 4th, 2005 was an enjoyable day. The only thing they said previously about whether or not something is a statement or not is whether or not you can determine if it's true or false. So what would you say?
Not a statement.
I would have to say this is not a statement. Why would you say this is not a statement?
Because it would be a joke with the you, but we hope
Perfect.
for another one.
Perfect. No, that's exactly what I'm looking for. So like, was it enjoyable for you? Maybe, Was it enjoyable for him? Not necessarily going to be the same, right? So depending on who was interpreting the statement, they would interpret it different ways. Now, if I said June 4th, 2005 was an enjoyable day for Bobby, right? Then it's different. It's either true or false. Does that make sense? All right. Meet me at 8 p.m.
Statement.
Not a statement.
Really?
If it says we met at 8 p.m., meet me at 8 p.m., I have no idea. 8 p.m. is later, right? Does that make sense? If someone says meet me at 8 p.m., they must be talking about later on that we're to meet. Is that correct? Can you say if the statement is true or false?
No, you can't because it's not happening.
Exactly. Does that make sense?
Yeah.
4 + 3 = 7 and 7 + 3 = 4. Statement or not a statement? See, you just did the thing I was saying at the beginning. You were deciding whether or not this is true or false to begin with. They're not asking me right now if it's true or false. They're just asking me if it could be true or false. Does that make sense? This is a statement. You understand? Brad Pitt is the governor. Statement. It ain't true, but it's a statement. Any question? Well, I guess maybe depends which woman you ask, right? So decide whether the statement is compound or not. This is just dumb. This is just saying if it combines two or not. Does that make sense?
Okay.
All right. So the robber is big. Compound or not? No. My handbag is heavy. If Lana meets her deadline, then Mary will smile.
Yes.
Yes, because there's two separate things here. Is that correct? Right? There's a statement here and there's another statement there. Is that right? Hannah likes science and Morgan likes red. I mean, that's even called a compound statement in regular English class. Is that correct? All right. Question? So when you join two independent clauses, we need an independent clause for each statement. Does that make sense? Write negation of the following statement. What would the negation of this statement be? Number 3.
Unlucky.
No. That's not the correct negation though. Because like if I say to you, her aunt's unlucky number is the number 13, right? The only correct negation of this statement is to say her aunt's unlucky number is not the number 13. I don't know what's lucky. Maybe this woman's never lucky. You know what I mean? So then her aunt's unlucky number is correct. The number 13. But that's it. That's all negation means. Does that make sense? All right, now let's just go into this also because we're going to go do this at the same time. This is our symbol for negation. This little like tilde up thing. Does that make sense?
Which one? Oh, the little squiggly.
Yeah, little squiggly.
Okay.
This, any statement we said has two possible cases. It could either be true or it could be false. right? So we list out these cases here. I list out all possibilities here. Does everybody see that? This is referred to as a truth table. We can use these tables to answer all the questions we need to answer in these things. And all you have to do is really understand what each table means and then be able to apply it. Okay? So to understand what not means, you have to understand this table. This table is very simple. It's almost so simple it gets confusing. But P, whatever statement we make, could either be true or false. Does that make sense? Then this means not P, or the negation of P. Does that make sense? Then if P is true, the negation of P would have to be false. If P is false, the negation of P would have to be true. Okay, that's our first truth table. Does that make sense? All right. Now it says write the negation of the following statement. X less than 20. What's the negation of X is less than 20? X is not less than 20 is correct. How would you write it in terms of math though? Perfect. Perfecto, sir. All right, so if I write here that you have 20 right there, and they say less than that, that's this garbage, is that correct? The negation of that would have to be all the other crap, so it would be that, but it would also include 20. Is that correct? So this side right here is X is less than 20. That side is X is greater than or equal to 20. Is that right? The sky is blue. Sky is not blue. The share is not on sale. Any question with this? Not too bad. Is that right? Existential quantifier. All are, some are. I really should ask this question before we do this. But what is the negation of all? The negation of all is really some are not. I'll explain in 1 second. Then if I say some are, what's the negation of that? None are. All right. So here, this part, this is where you're gonna start seeing, like, you're gonna learn very quickly. You hate it. English sucks. Let's see why you won't. Listen, wait till I write some of this stuff, and I'll be like, go read the English, and then I'll write the math when we understand it a little better, and you'll be like, I'd much rather do the math because English is just tough. English is, you know, is long sometimes when you write.
Learn the definitions of.
It's not even just definitional words though. The problem is the way people phrase things sometimes in English. I can show you, we'll do things where I just move a comma. And all I do is put the comma in the wrong place and the entire sentence has a completely different meaning. You know what I mean? It's like these types of things. I'm not saying you can't read. I'm just saying that when you go and read, it's hard for all of us to read certain phrase statements. Does that make sense what I'm saying? You know, so like the, no, I just said it again. Anyway, so so this, so if I say to you, if I say to you, he has all the dollars in the room in his wallet. Okay? And then he turns around and he's like, no, he doesn't. Does that mean that he has none? No. Does that mean, what does it mean? It means somebody else pays him the package. Is that correct? Does that make sense? At least one of the dollars doesn't have. That's all it means. Does that make sense? Doesn't mean he has none, right? I said you have all the dollars. Someone turns around like, no, he doesn't. I mean, you got nothing. Does that make sense? Right? But that's what we just said. We just said 2 seconds ago when I asked you what's the complement of all are, you said none. All right, it's not true. It means some are not. Does that make sense? All right. If I say to you, he has some dollars in his wallet. Some dollars in his wallet, right? And then she's like, no, you're lying. And how much does he have in his wallet? Nothing.
Nothing.
If he doesn't have something, he has nothing. Is that correct?
Mhm.
You understand?
Mhm.
It sounds simple, but it's very easy to make a mistake on. Okay. Negate the following statements. Some dogs are brown. No dogs are brown. Not all.
Oh, that was a-
But you get what I'm saying. It's easy to make an error here. You see this, right?
Oh, so you just write down the opposite of.
They just want you to negate the statement. So write a sentence saying
Opposite of.
correct.
Gotcha.
All people wear black.
No people like that.
What do you say?
No people.
Some people don't wear black.
Yeah.
Does that make sense?
Okay.
Because if I say to you, all of them do, right? You wear black, he wears black, everybody wears black, right? And then someone turns around and is like, no, that's not true what you just said. It means there only has to be one person here who's not wearing black. Does that make sense? Someone doesn't. Does that make sense? Not necessarily all of them. Okay? Some people do not wear black, right? But you see how simple this is so far? And it's already like, if you try and do the English, it's already a little shaky. Does that make sense? All right. That's why they came up with all this math garbage for this stuff. Some cows do not have hooves. I don't know. I got to think. Some cows don't have hooves.
Not all. The opposite, you know, the opposite. Some cows do not have one. All cows.
Have
all
hooves.
cows have hooves.
All cows have hooves. You're right.
Thank you, I appreciate it.
No, you're right. So then the no juice has sugar. Some juice. Some juice. Some juice has sugar. Because you say no juice has sugar, you're saying that the number of things that have juice is equal to 0. Does that make sense? The complement of that means that J would have to be greater than 0, or it means there's at least one that has juice. Does that make sense? Right? Not all of them, though. Does that make sense? Now he actually wants me to see, or she wants me to see if this is true or false. Okay? So every integer is rational. True or false? False. Every rational number is an integer. Okay? But not the other way around. Not every whole number is a natural number. True or false? False is correct. All whole numbers are natural numbers. Does that make sense? Wait, excuse me. It's backwards. True. The original statement is true. Not every whole number is a natural number. 0 is not a natural number. Does that make sense?
Right.
This one's true. There exists a real number that is not a rational number. True. Any irrational number is not rational, but they are real. Does that make sense? All integers are real numbers. No, all integers are real numbers. Because the integers are inside here, and then real numbers we said were outside.
Oh,
there.
yeah.
But that one's a little bit specific, that stuff. All right, so now they mention these symbols here, and, or, and not, okay? They just want us to rewrite the statements using the symbol in English. So it says P represents she has green eyes. So what would this statement be? What would it be though? What's the statement?
It's not P. No.
She doesn't have green eyes, is correct. They just want it in words. P, well, this one means and here. So you just write and. She has green eyes and he is 60 years old. Does that make sense? that make sense?
Yeah.
What about this one? This one's or. She doesn't have green eyes or he is 60 years old. Does that make sense?
Yeah,
All right, this last one is the only one that's confusing, okay? When they do this, the not has to apply to the whole thing. So the way I typically say this is, it is not the case that that's and. She has green eyes and he is 60 years old. Does that make sense? I didn't change anything. No, this says he. Q says it. You understand? This is just what it says. I just have to use their statement. Question? Anybody? This one means negate. This one means negate. This one means and that one means or. And I did write these on the board here for these charts and stuff like that. So when you get a chance, okay? Just when it says not in the front, you just gotta write is not the case. The rest of it is the same. This just says P and Q. Does that make sense? I really don't like getting into the ands, nots, and whatever until we do these things. Okay, so they haven't gotten to it yet. We'll do it shortly. Let P represent the statement the chair is broken. Q represent I get an A. Convert the following statements to symbols. All right, whatever. What is this one going to be? The chair is broken and I do not get an A. So that's P and what? Not Q, I guess. Does that make sense? Good? Does it make sense, guys?
I just didn't remember these symbols.
Right, but we just started it. So the chair is not broken, so this is not P or, right? And the and is kind of easy to remember because it looks like an A.
Mhm.
Does that make sense?
Mhm.
The or, Q is correct. I get an A, so that's Q, or I do not get an A. Okay, that thing. Does that make sense? Any questions so far? Should be okay so far, right? Okay, that was the first section. See, I told you they'd get to these truth tables pretty soon. All right, these are the same things I've written on the board here. I don't like the way they've written, okay? Let's do it the way I'm writing them. I probably already wrote this up, so I'm just gonna go back to my old notes. Where did I write it? On the first one, I guess. All right, so we just went through this one before. Negation, is that correct? Right? So, and I'm just writing out the symbols here also, not and or implies, all right? So sometimes they say implies here, sometimes they say if, then, all right? Either way you want to think about it. All right, you should think about if then, excuse me. All right, so negation. Usually these are the variables we use for this stuff, P, Q, R, S, T, stuff like that. We're not going to deal with situations with more than 5 different statements, okay? Not P or tilde P means not P or the negation of P. The truth table of that, we already saw that before. Is that right? If I say let P be, it rained today in Miramar, that statement's either true or false. If we say not P, then it did not rain today in Miramar. One of those two statements is true. One of those two statements is false. Is that correct? For each variable or statement, there are 2 cases or possibilities, true or false. Any question here? This one we already did before, but any question with this? All right, so first type of thing, which should be fairly obvious, but it's worth mentioning it. If I say not something, it's the something then. The two nots just cancel really. Does that make sense? Right? So when if they write not P, that's just the same thing as P. Does that make sense? Let's just see a proof for that using a truth table. So then maybe finally, hopefully we can see a little bit of, we won't be able to see all of it yet. But we can see a little bit of why I'm saying that these truth tables are helpful, okay? So this is how simple it will be for you to prove what I'm saying. Okay? So to write out a truth table for a situation, you need to write out all possible cases. If something is true or a statement is true, it has to be true in all cases. Does that make sense? So we just write out all possibilities for people. You can produce true or false. Right? Even if I say tonight of rain and Vermar, we don't decide whether the statement is true or false. We just say it can be true. Does that make sense? It's the same. Until they tell us a little bit more to tell us whether it's true. Right? Not P would then be in the first case, if the original thing was true, not P would have to be false. Right? But then not P is the negation of that. Therefore, that would have to be true. Is that correct? If P is false, not P would be true. Is that correct? If not P is true, then not P would have to be false. Right? These two cases here are identical to the original thing. Therefore, whether I wrote this or whether I wrote this doesn't really make a difference. Does that make sense? It's like saying to someone, turn left, turn right, or just don't do anything, right? Does that make sense? Right? Question? So quantifiers, some dogs are brown. Some, we say there exists a dog that's brown. All people wear black. Some people don't wear black. That was the contradiction or the negation of that. Some cows do not have hoofs. No cows do not have hoofs. Does that make sense? In other words, all cows have hoofs. Does that make sense?
No, what I said.
I'm just doing it the way they did it on the worksheet. Does that make sense?
The way I said it makes sense.
I like your way better. I was just doing it the way they did it on the worksheet because that's what they said. Yours is like actual English. So then the like nobody talks like this. No cows do not have hoofs unless you want to confuse the shit out of somebody. No, but you'll see when you, after doing this, and you listen to these politicians, like that's all they do. You know, it just sounds fancier. It is not the case that there was not a time when there was not a person, you know, and it's like they just talk like this to sound fancy. So like it drives me nuts, honestly. Because I know the only reason why the person is doing that is to try and trick people. All right, so let P be it rains today, let Q be I go to school today. Now each one of these statements has two possibilities. Is that correct? So P could either be true or false, but then Q could either be true or false in each of those individual cases. So then P could be true and then Q could be true. P could be false and Q could be false. Q could be true and P could be false. Q could be true and P could be false, etc. Does that make sense? All right. There's 4 different possibilities. There's 2 for each one. Does that make sense? So 2 times 2 is 4. All right, so let's look at this now with and or. He keeps trying to say you got bad breath. So the no, thank you, I appreciate it. You can just say I have bad breath, it's all right. So the you're too nice, you know. So like the this and they refer to it as conjunction. Guess what? You've always referred to this as conjunction. When you do it in English, they say and, or, and but are conjunctions. Is that correct? Right? So in math, they try to get a little bit more specific. They're like, well, the or is not exactly the same as the and. So they call it disjunction. Okay? Does everybody understand? Conjunction is and, disjunction is or. Does everybody see that? All right, but we gotta understand what this and or nonsense means. So this P, I said could either be true or false, right? If P is true, Q could either be true or false. Is that correct? If P is false, Q could either be true or false. You see the way I've written this? True, 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 false, false, true, false, false. Don't ever write it a different way. Just always keep writing it the same way. Because after you write these things out a couple times, you're going to remember it. And the more accustomed you get to writing it out in the exact same order, the better and easier it's going to be. Does that make sense? All right. So all I did here was I was like, oh, P could be true. If P is true, Q, what could Q be, right? Then once I've established all cases for P being true, then I change P to false. Then I establish all cases for when P is false. Does that make sense? All right. So in the first case, P is true and Q is true. In other words, the statement "it rains today" and the statement "I go to school today" are both true. Now I make the compound statement. It rains today and I go to school today. I think it's clear that that statement is true. Does that make sense? Both the individual parts are true. Is that right? Now, if I say to you, he's wearing a red sweater and he's wearing a red hat. Is that true? No, I'm psychotic then. If that's supposed to be true. Like he's obviously not wearing a hat. Is that correct? Right? What if I say to you he's wearing a red sweater or he's wearing a red hat? That's true. Does everyone say that? Well, I know you know what and or means. We already did it before. And I know you knew it before we started this class, right? But now we just want to be very specific. Okay? So if I say to you, it rains today and I go to school today, but I didn't actually go to school today. I go to school today was false. Well, then P and Q would be false. Does that make sense? All right. Now, if I say to you, it rains today, but it didn't actually rain today. But I say to you, it rains today and I go to school today, but I did go to school today. My statement is still false because the first part of it was false. Does that make sense? All right, Tim?
Yeah.
Question?
No.
Now, this one's kind of easy. If I say to you, it rains today and I go to school today, and it didn't rain, nor did I end up going, the statement is obviously false. Then both things I said weren't true. Is that correct? You understand? All right. Now, I wrote in here in this yellow part here when this statement, when and is going to become true and when and is not going to be true. And is only true when both P and Q are true. Okay? And both. Is that right? Just like you before, you had to be in both sets. All right? It's false when either P or Q ends up being false. Does that understand? What was your question? I'm sorry.
What's that?
This one's called disjunction.
Oh.
Right?
Oh,
Those names aren't really that important. I just don't know if they're going to ask you on your test, so that's why I'm telling you. Does that make sense?
As you, I thought it was a V.
Yeah, no, I can't write very well. All right, it rains today or I go to school today. Now this is or. All right. If either of the two statements are true, the statement ends up being true then, when it's or. The only way for or to be false is if both things are false, right? If I say he's wearing a red shirt and he's a female. Now I just said he is a female. He is a female is definitely a false statement no matter what situation
Of course.
right?
Right.
Well, I guess people can make up whatever.
Yeah, you're right.
Well, let's say traditionally, okay? Traditionally, with the term he, right? You don't usually refer to somebody with a big gender as he. Usually, most big gender people not. But it is their choice. It doesn't really, who cares?
Whatever they want.
To use anything, right? So the thing is, but generally, he refers to male, right? So, now if I said, he is female, right? Somebody's kind of wrong with that statement. Does that make sense what I'm saying? Or it could be stated better. Does that make sense what I'm saying? Right? So if I say to you, he's wearing a red sweater and he is female, but we're claiming he's not female, right?
It's false statement.
When I say and, it's false, right?
Mhm.
When I say to you, he is wearing a red sweater or he is female, right?
Now that could be true.
It is true. It is true, period. You got it. What I said is true. Does that make sense? True, or you only need one or the other. Does that make sense? Or both. Okay? Question? All right. It's true when either P or Q is true. Okay? But it's false. Only when both of them are false. Right? If I say to you, he's wearing a black shirt or he's wearing a black hat, well, that's just not true, right? Question? Sorry, I just liked your sweater. Anybody got a question with this? You understand? But these particular charts, there is no other way to do these questions. You must know that this is the definition, effectively, of what and or means. Does that make sense? You get it? So anytime you refer back to these tables, and it has to give you the answer. All right. All right. Tautology. There's something referred to as a tautology, and there's something called a contradiction. So this is the other thing that you will constantly hear politicians say, and they sound really good, but there's sometimes these nonsensical statements. So tautology specifically means any statement that is always true. All right. So like if I say to you, he is wearing a red sweater or he's not wearing a red sweater. That's true. Does that make sense? So P or not P, always true. Because if P is true, not P is false. True or false is true. Does that make sense? True or false, right? If P is false, then not P is true. False or true is true. Does that make sense? Guys?
Yeah. Either way, it's true because it's absolute.
Let's not say absolute. All or means is one of the two things has to be true. At least one of the two things has to be true for it to be true, right? In this case, one of the two things is true, therefore it's true. In this case, one of the two things is true, therefore it's true. Does that make sense? Do you understand? Whereas if I say he is wearing a red sweater and he's not wearing a red sweater, that doesn't make any sense. That can never be true. Does that make sense? Right? So a contradiction is an example of a statement that's always false. I wrote here, it rains today and it does not rain today. If P is true, not P is false. But then if I do true and false here, it would be false. Is that correct? If I do false and true here, it would be false. Does everyone understand what I'm saying? Does it make sense, guys? You understand what I mean by contradiction in tautology? Contradiction, just if all the cases end up being false. So like any statement that's made where it could never be true, it's referred to as a contradiction. Does that make sense?
Yeah.
This is just an example of one. But in general, do you understand what I mean by contradiction? So what was your question with this? P can either be true or false. You have some statement. Can either be true or false, right? If P is true, then what's not P? Okay. Then if I say to you P and not P, some true statement and some false statement. What would that be? Why? Well, you gotta know. You can't tell me that. Do you know what and means? I know you do. So then I know you know what this means. Okay, so if I say to you right now, you got a backpack, right? And you got a pretty pink dress. But I don't see any pretty pink dresses, okay? My statement's obviously false, is that right?
Mhm.
Right? Because one part, there's a compound statement I gave you, right? One of the two parts ended up being false. When I say and to you, both of them have to be true for it to be true. Is that correct? Right? So the thing is that this is saying and here. It's joining these two statements. One of them is true, one of them is false. Same thing where. One of them is false. One of them is false. So this is what and means. Does that make sense? All you ever do is you just look at it. Oh, or. Oh, this is true. Good. Does that make sense? Okay. Question? P just stands for a statement. In this case, I said P was, it rains today, okay? Any does that help? Somebody else had a question? But do you get what I mean that sometimes it's actually so simple in math that it confuses the shit out of me? Okay? So what you just got to do is just try and find out why they're bothering you with it. And then once you do, you'll be like, oh, because they're trying to explain what and means, or they're trying to explain what or means, or something like that, right? And you'll be like, wait a second, I know what that means. So what the shit are they trying to say, right? And then all of a sudden it'll start working. You got me? The problem is generally when I'm learning these things, the first thing I do is start thinking of everything else but what they're trying to talk about. Find the truth value for the compound statement when P is false and Q is true. In other words, they want us to do false and true. What is that? False. Does that make sense? Good. All right, what about the next one? This would be true or not false. How do we do this one? True. Because this thing is true at the beginning, it automatically has to be true. Does that make sense? So I don't really need to do what I'm about to do right here. But we can simplify this also because we can actually do, I guess, not F. Not F just means true. Is that right? It's really true or true. But once I know that this one's true, I don't need to proceed. I can just automatically answer it. The squiggly line means negation or not. All right, what about this one?
Not false. Not false. True.
What's your final answer?
True. True.
So this says false on the inside here, right? It's an and statement. That means this entire thing has to be false. Therefore, we negate the false and it must be true. Does that make sense? All right. Or just do it out. Not false and not true means false. False and false is obviously false. So not false is true. Does that make sense? Does that make sense?
Is not false.
No? No, we do it again. So then this thing here, false and not true, right? Not true. That's false, right? Now, the only thing you ever can do is do whatever's inside the parentheses. That's all parentheses mean, right? So false and false. So I make two statements. They're both false. And I say and that they're both happening. No, I'm a liar. Is that correct? You get what I mean by that? Right? He is wearing a black sweater and he's wearing a white hat. That's not true, right? So like this, false and false is false, right? Negate false. Okay, it's true. Because you just switch it. That's all it means. You got it? You guys got it? All right. Now, I don't really like writing out things the way I've been doing it so far because I'm writing too many steps, and honestly, that makes it more confusing. All right. When someone has not P and they tell you P right here, don't write down false somewhere. Just do the not right at the beginning. Does that make sense? So what's not P? No. You have to say true or false. Not P is true is correct. Does that make sense? What's not Q? False. Good. Now all we have to do is T or F, right? Now, then it comes back to these tables. These tables, true is correct. These tables are the only meaning of these things, okay? So when you take your test, the first thing you should be doing is writing down the table. Does that make sense? Does everyone understand? All right. Believe it or not, there's a bunch of questions on the test that force you to write it down anyway. And students still tell me they don't know the answer. But you write down this table a couple times when you're doing the question. Like every time when I was in school and I forgot this stuff, I would just write the table down when I was doing the question. I swear to God, it takes you 3 times. You write this down 3 times, I guarantee you're gonna remember the table. All right. You write it down 5 times, you're never gonna forget, probably. My teacher, when I was in school, she told me you have to write something down 38 times. When you write down 38 times, then you're gonna remember. I have never written something down 38 times. All right. But I guarantee if you sit there and start writing it down, you write it down 38 times, you're gonna remember too. You'll remember with less also, but whatever. You'll remember with 38. All right, here, what are we gonna do? Just tell me what to write. False is correct. Good. True and false is correct. False, good. Or, yeah. False is correct. True and false. That says and, right? No, so this is false. Does everybody see that? What's false or false?
Wait.
He's wearing black shoes. Or he's wearing green. Is my statement true?
It's both false.
No,
And
because both are false. I never say anything true. Is that correct?
Right.
Or just means either one. And means both. Does that make sense? All right. You're on both streets. You're on either street. Does that make sense? Falso. Oh yeah. Also, like this, like, thank God we're doing this on the computer, honestly, because when I grade the exams, usually all I see is this garbage. I don't know what the shit that is. Like, it's very tricky. You got me. Okay. It's very tricky. But it is. No, people do it by accident. People do it by accident. They don't even do it on purpose. You know what I mean? No, but it's not, because then the math teacher is just gonna mark it all wrong. So like, I put both. You like that? All right. So no, the only reason why I know this is because I'll say it. Like, don't do that. And then I'll sit there and keep writing and writing and writing and writing, and then I'll do it by accident, you know? So it's just, it happens. Find the truth value for the compound statement. P is true, Q is false, R is false. Yeah, whatever. All right, so P is true, R is falso, not Q is cierto. Okay, so now what?
Yeah, this is true.
Now, like, just once they put an or here, right? And that part is true. It's already all true. Does that make sense? I don't even care what happens over here. You guys get what I mean by that? All right, so we could just say it's true. We don't even need to figure this part out, really. But if we wanted to figure this part out, that would be false. False or true is also true. Is that correct? Question? Yes. Yeah, but you gotta, oh, of course. But the thing is you gotta know it the way I'm saying it too, because the problem is that, so I'm giving you shortcuts. All right, and then sometimes they're gonna be helpful to you. So right now it's too new. You know what I mean? We haven't done the homework and all that stuff. Definitely use the table every time at the beginning until you remember what the values. Okay, but also I want to be able to not necessarily have to figure every single thing out to necessarily figure out the answer. So all I'm saying to you is that if you have an or statement and one of the two statements is true, right? In this case, something is true. In this case, something is true. In this case, something is true. We see all of them are true. All I'm saying is or needs one of the two statements or both to be true. So once I already know one of them is true, then by the table, you know it has to be true. Does that make sense? You always use the table, always. Okay? It's just sometimes some people waste more time doing it than others. Does that make sense? Question? Not.
No.
Good. Yes?
How many classes are in?
No idea. Honestly, there's one thing I can tell you that in any class that is not helpful to prepare for the exam is to know how many questions there are. Because if I tell you there's 1,000 questions, is that good? That's terrible, right? If I tell you there's 5 questions, is that good? No, because the minute you miss something, then all of a sudden you start flunking it also, right? If I tell you there's 30 questions, is that good? No idea. Hard, I don't know if they're long, I don't know if they're short, I have no idea. So I'm just telling you, don't ever bother with how many questions there are on the exam. It's the professor's job to supposedly grade the exam and do it correctly and all that other stuff. If the exam is too long, the professor must curve the exam. If the exam is too short, honestly, that's what you should be more worried about. Do you know what I'm saying? Because then I can't curve it, you know? So what I would say to you is always try and focus on what's actually on the test and whether or not you know the material. I know where you're coming from with this, and I am not blaming you for asking that. Every single class I've ever been in my entire life, people ask this question, you know what I mean? But honestly, I always turn around with the same thing. Because I had to go to these, when I used to work at FAU, they sat there and they made me go to these like teaching things and supposedly learn how to like teach the class or whatever. And they didn't teach me shit. And I was like worried about it because I was like 20 something years old and I was going in this room and they're like, you're supposed to teach. And I was like, me? I was like, I'm the one that never went to school. I'm like, you don't want me to teach, right? They're like, no, you'll be fine. You'll be fine. You'll be fine. And then I see the people around me and these other kids that were teaching, and they were bad. Some of these kids, not saying that I was that great, but they were bad. Okay. And then they would come in there and we would have to go over what was going to be on the exam, right? We have to decide, hey, what's going to be on the exam? Everybody has to take the same test. All the kids are going to do this, whatever. The test is going to be 57 questions, going to be on this, that, whatever, all this stuff, right? And these people would come in there and start asking how many questions are going to be on the exam. And the guy who was running the whole thing would constantly turn around to them and say, I'm not going to tell you. Everybody has to take the same test. We've been doing it for 45 years or whatever, right? The test is the test. I can't tell you what's exactly going to be on the test because I know you're going to go tell your students. I can't tell you exactly how many questions are on there. We haven't finished making it yet. And these people would come in every single time and they'd ask the same question. And I finally got up one time and I yelled at them and I was like, can you ask something that's going to help us? Can you ask them what the shit is going to be on the test instead? Like which topics, so I can figure out what to teach my kids, right? But these people would come in and do the exact same thing over and over and over again. And then I was in classes with these same people eventually. And they would flunk all the classes that I was in. And they're math teachers at these colleges here. I swear to God. All right. And I'm just trying to tell you, there's some things you can ask in the classroom and you can get a lot from it. There's some things you can ask in the classroom and no matter what answer the teacher gives you, it's not going to really help you that much. No matter what I do, if I tell you how many questions are on the test, I don't think it's going to make any difference in how you should prepare for the exam. Does that make sense? You just do your best, make sure you learn the material, right? And then do your best when you take the test. And that's the best you can hope for. You know what I mean? what am I gonna do? Like go and sit there and study 15,000 times more because I told you there's 1,000 questions on the test? Honestly, you tell me there's 1,000 questions on the test, I'm probably not gonna do shit. What am I gonna do? You know what I mean? So anyway, I'm just explaining, all right? I don't know. I don't wanna make you feel bad or anything like that, but I'm just trying to tell you that doesn't seem to help most of the time. All right, enough babbling. Okay, so let's try and do this a little bit more quickly. All right, I can do P and Q. True and false. So what would that be? False is correct. Might as well just write false there. Does that make sense? Right? And then I can really just change that immediately to true. Is that correct? It's got the not. Is that right? The more you do these things, the easier it's going to be for you. Does that make sense? All right. You can write it all out. It doesn't really matter. It doesn't take that long, but it's a lot to think if you do that sometimes. All right. R or not Q. All right. So R is what? What's not Q? True. So what's this inside part here? True is correct. Does that make sense? Because it's false or true. False or true is true because one of them is true. I haven't talked about that. You can, but you have to do it the way we talked about it last time. But we haven't talked about that yet. I'll mention it in a second. Soon. All right. So then this is true here. So now what is this? True is correct. Does that make sense? Does that make sense? Anybody have any questions so far? All right. So this thing says not, what's not P? False. All right, I'm not doing the rest of this shit. What's the answer? Final answer should be true. Does that make sense? Because this says false and something, right? But it's an and, right? But they're already telling me one false statement. They're sitting there and saying he's wearing a white hat. He ain't wearing a white hat, right? Okay, this inside part is false then. So this is not false. Okay, good. It's true. Does that make sense? All right, now I'll write it out anyway because I said I don't want to sit here and not write it out. All right, not Q and R. Not Q, that's true. And R is false. And here is false. False and false is false. Not false is true. Does that make sense? Question? Can you already see though why people like this better than algebra? It's not algebra. No, anybody tells you they like algebra, I'll give you some more algebra. I'll show you what we'll get to. No, I'm kidding. I like all this math crap. It's just learning some of it is, it gets a little heated, let's just say. Sorry?
Yeah, you guys lost me. Your actually lost me. When y'all were teaching about pi times radius. After that, everything is went downhill.
We do that in this class. I got you with that. You'll see. I'll be able to explain.
Anything else?
It's 2 pi r though.
2 pi?
Yeah, it's pi times d. Pi times diameter. Yeah.
Only that and based
That's our next chapter. Yeah. Geometry. So then, all right. You don't have to know that much more than that to do our geometry, actually. So you'll be good. Create the truth table for not P and Q. All right. Now let's just also do this statement also. This is the same thing by De Morgan's laws as this. We talked about De Morgan's laws before. When you take this, you distribute it to this, distribute to this, distribute to this. Is that right? If you distribute this to P, you get not P. You distribute this to the and, you get an or. If you distribute this to the Q, you get not Q. It turns out De Morgan's laws hold in this setting as well as the previous setting we talked about. All right. So I don't know if you recall, but when we did sets before, we said that if you have not a, what did this thing say? And not a and B, then I drew this picture. It was all of this stuff, but the thing in the center. Is that correct? Then I said that there's another way we could write this. We could say not. Sorry, they wrote not like that before. This is not A or not B. And then I said that this is really going to end up giving you the same thing, right? Not A is that stuff, not B is that stuff. The only thing that's not shaded is the thing in the center. Does that make sense? The same thing's going to happen with this. One way you can start understanding that these two, this diagram and our truth table are actually two different ways to describe sort of the same situation. All right. So what do I mean by that? Like if I label this, let's say we call this P's house and we call this Q's house. All right. And then I label these regions here. Let's call it 1, 2, 3, and 4. Okay. We just said that you have P, Q, and P could be true, then Q could be true. P could be true, Q could be false. P could be false, Q could be true. P could be false, Q could be false. Is that correct? If you had to pick a region that each one of these things correlated to, which region would you select for the first one? True, true. 1, 2, 3, or 4? Which one?
True, the open probably center.
3 is correct. Does that make sense? Because they're both, because you're in both houses, right? That's the only place you're in both houses, right? If I said you're in P's house and you're in Q's house, right? The only place where that would be true is in the center. All right. So what about this one? 2 is correct. You're in P's house, but you're not in Q's house. Is that right? Does that make sense? Right here, right? P is true, Q is false. Is that correct? What about this one? 4 is correct. And then false, false is definitely 1. Is that right? Right? In other words, each of those cases was really associated with a region on the previous diagram. Does that make sense? So there is a relationship here. Does that understand what I'm saying? No?
Oh, yeah.
Sorry, I just didn't hear. Question with this? In other words, every single one of these questions, I can do them with set diagrams. Every single one of these questions, I can do them with truth tables. Either way, right? Okay. All right, so let's prove De Morgan's law applies in this particular case. Let's also find not P. Let's also find not Q, because I want to do not P or not Q also. All right, let's do this whole truth table here. But you are going to help me. What do I write here? Nope. What did I say to write here? True, and then what's Q? True, no. Start off with things being true first, then start trying to change them. What's this? True, false is correct. False, true. False, false. And those are all possible cases. Is that correct? Again, if you get in the habit of writing the exact same things over and over and over again, there's less to remember. All right. It's not even, well, repetition and there's less to remember. Okay. That's the question they're going to ask you. They're going to ask you to fill it out. Okay. Some of them, they might fill out some of it, but not all of it necessarily. But those are the ones we have to know. All right. This one we haven't even gotten to yet, or these two. Right. Yep.
I did the conversations with the word that I used in this moment. I did it
You talking about discussion?
discussion.
No, we don't. You don't have to do discussion.
I did discussion.
We don't have to. No, I told everybody the first class and everything. We don't have any discussions in this class. I'm not making you do discussions. Pretty much. Sorry. Sorry? Because you'll see very soon you won't be able to do it without doing it. That's the only way to tell if the statements are true and stuff like that. You have to check in all the cases also. When they start making too complicated of things, you're not gonna be able to do it in your head without writing it out on the table. All right. All right, what's this? True is correct. What's this? False. True and false is false. Is that right? What's this one? False. And then last one is false also. Does that make sense? Does that make sense, guys? Right, because that's the same thing from there, right? We're just doing it now for this question. Does that make sense? All right, so what would this guy be here? This says negate this one, so we're negating column 3. Is that correct? So then this is false is right. Does that make sense? What's the next one? True, true, true. Does that make sense, guys? Not P. Now I have to go and negate everything in column 1 now. Is that right? You get it now? So then this is going to be false, false, true, true. Also, like it's so much easier making the table than doing it in English. Wait till we get to the ones where you have to draw logical conclusions. And then I'll look at it and I'll be like, oh, you do this, 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 it's true, right? And then I'll write out the table and you'll be like, so much easier. Okay? Not Q. Does that make sense? Same Fort, you okay? Everybody okay so far? What about the last one? No, because it says false or false, right? Because it says use the not P, that comes from here. Use the not Q, that comes from here, right? That's why I made these 2 columns here, so it's gonna be easy for me to figure this one out. Does that make sense? So then this is gonna be false. So really all I wanna do is, I just wanna do false or true, true or false, true or true. Does that make sense? All right, so what's the first one? Both statements are false, so the overall thing is false. Is that right? What's the next one? Because it's an or, it'd be true. Because it's an or, it'd be true, and then or is true. And then what we notice here is that these 2 particular columns, for all possible cases of whatever P and Q mean, these statements are exactly the same in all cases. Therefore, the statements are equivalent. Does that make sense? Does that make sense? And this is why you want to use these tables, because you can write out the whole table and it doesn't take that long. And each individual step is actually fairly easy as long as you remember these things here. And then we can determine whether or not these complicated things are actually the same or not. Does that make sense? Or when they're the same. Question?
How do I schedule tutoring?
I'll show you afterwards. I'll show you afterwards. You just click on academic resources in this thing here. Actually, whatever. Let's just show everybody real quick. So resources, academic resources. Okay. After you click academic resources, then you click academic success center here. All right. Once you click academic success center, then it says you can schedule a tutoring appointment. Let's say we want to do it on South. So I click South. After I click South, then all I do is log in here and then that's it. You can pick it then.
You pick the date?
Mhm.
Oh, okay, all right.
They'll show you what's available and stuff like that. All right. Now, what I recommend with this tutoring thing is just set it up right now for the whole stupid semester.
Yeah.
Just take everybody else's slots.
Yeah.
No, I'm not kidding. No, do it. You sit there and you do each one, right? And then you have your spot.
Mhm.
Let them worry about scheduling it with other people. You know what I mean? Because your tuition pays for this. So
Okay.
you deserve to get the tutoring. You know what I mean? So I don't know. Mm-hmm.
Can you write these down for me because I don't want to forget who you know.
Well, let's do it afterwards then. Or actually, I can send you an email also. Is that good? We'll talk about it afterwards. All right. Not P and not Q is this. Oh, wait, I just did this. No, I did the other one. Shit. All right. So then this, P is true, Q is true. P is true, Q is false. Then P could be false, Q could be then be true, P could be false, and Q could be false. Every time we write that part the same. Is that right? Not P, all I really do is negate column 1. Is that right? So then that would be what? False, false, true, true is correct. What's not Q, then I would negate column 2, I guess, right? What would that be? False, true, false, true. Okay, now, the only thing is that they want us to show that these two statements are equivalent here. Does everybody see that? Now, I haven't really explained to you 100% how you go and figure out what to put up here yet, okay? But can you figure it out? What should I try and do next? You're gonna say something? Not P and not Q is correct. Because I've already have not P and I already have not Q, might as well figure out not P and not Q. We have to do that already. Is that correct? If we want to see these two things are equal to each other, we need to construct the truth table for this statement and this statement separately and see if they're the same in all cases. Is that correct? All right, so not P and not Q. What do I write here now? Because we do and. Is that right? So false, what else? False, because it's and, right? Does that make sense, guys? What's the next one? False. True. Does it make sense, guys? What do we do next? We might as well do P or Q first. Does that make sense? Because we need to do this, so then we might as well do that part first. Is that right? So we do P or Q. You understand? We could have done not P and not Q because I already proved to you it's the same thing from before, but that's not what they want here. All right. What's this? There you go. True. True. Because we're doing or now. Is that right? True, true. What else? True. False. Now, every single person in here should be able to answer that question than what we just did, because it is literally just reading this table. It's the exact same thing. Does that make sense? All right. Okay. What do I do now? Negate it. Try not to say reverse. Because reversing actually means more later. All right. So then this, not P or Q, right? Right. We already have P or Q, so we should be able to negate it. Is that correct? All right. So what do we got here? False, 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 true is correct. And then we notice that what? That this and this are identical for all cases. Therefore, the statements are equivalent. Does that make sense? Honestly, that means a different thing in every math book, but yeah, that means they're equivalent. Sometimes people say there's something called equivalence classes. So when things fall in the same equivalence class, then we write that symbol. And then that means, in this case, we're trying to establish whether things are either true or false. So since we're establishing that these two things are always going to have the same truth value in all cases, they're equivalent. So this, you could just think of the symbol as equivalent, okay? So now he does more stuff. So it has an additional R here now. Does everybody see that? How many total cases will there be now? Well, there'll be 2 for this, true or false, 2 for this, true or false, 2 for this, true or false. 2 times 2 times 2 times 2, because now you could have P being true or false. Then Q could be true or false. Then R could be true or false. Does that make sense? So there's 8 total cases. Did you ever see that? 1, 2, 3, 8. Does that make sense? Because each one branches 2 times, right? That's why we're multiplying by 2. Is that correct? Also, I said to you way back, I think the first day, like if this is P and this is Q and this is R, You have two choice for this one, two choice for this one, two choice for this one. I think we call it the fundamental rule of counting or something like that. That all we need to do is multiply these things. Is that correct? There has to be 8 total cases. Does that make sense? All right, so he writes 8 things here. All right, so how are we gonna do this? Oh, well, I guess P could be true, Q could be true, R could be true, right? Just do the same thing I was doing before. Now I could switch the R to false. Is that right? Now I've established all cases when both P and Q are true. Therefore, now Q needs to be false. If Q is false, R could be true, and R could be false. Is that correct? Does it make sense?
How does R relate?
R is just some other statement. It doesn't relate. Some statement. So then now I've exhausted all cases where P is true. That means P must be false now. If P is false, now Q and R could be true. Right? And then R could also be false. Now I've exhausted all cases where P is false and Q is true. So now we have this. Does that make sense? Again, if you write this table out each time, it's the same thing every single time. All right. They don't usually do more variables than this, but they could do 4. All right. Question? You understand so far? Question? All right, somebody help me. Somebody do not P for me. True. Does that make sense? Not P and Q. So that's these two, right? False because it's and. Does that make sense? Then what? False. 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 True. True. False because the Q is false. False. Does it make sense? All right. Not P and Q and R. So now I have to do this and it with R. So true and false is false. False and false is false. True and false is false. So wait, let me just say also, because like, honestly, I don't like doing this all the time like this and going through every single one of them. Once I start seeing it says and here, every single time any of these says false, I'm just going to make this false. Does that make sense? So like this has to be false. 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 Then we only have to do 2 of them. Does that make sense? All right. Not that it was taking that long to do it in the first place, but I'm just saying like this helps me when I'm doing my test. Okay. So what about this one? True is correct. So we have true and true. Good. What about this one? False is correct. And then that's it. We're done. Does that make sense? Not too bad. Is that right? Now I'm telling you again, you don't go and do the homework and you wait. You ain't gonna remember nothing by Thursday. Nothing. You'll be like, what? True? Cierto. The number of compounds statements determines the number of rows in the truth table. If the n statements, there are 2 to the n rows. Yeah, I just said that. You multiply by 2. Give the number of rows in the truth table for the compound statement. So like this has N, W, and M. There's 3 variables here. Does everybody see that? That means there should be 8 rows. Does that make sense? There were 3 variables here, right? Where do you see 4? There were 3 variables here, right? And there were 8 rows. 2 times 2 times 2. Is that correct? And there's 3 variables here. This is going to be the same thing. You can just rename them if you wanted to, right? M, you could call it P, N, you could call it Q, W, you can call it R. Does that make sense? There's only 3 variables. Does that make sense? What about this one? Is that how many there are? 5? 6, it looks like. Isn't there 6?
No.
1, 2, 3, 4, 5, 6, no? Okay. 2 to the power 6 is 64. Hopefully they don't give me that question. I don't want to write out 64 rows. There's 6 different variables. 2 to the power 5 is 32, times 2 is 64. 2 times 2 to the power 6, right? 2 times 2 times 2 times 2 times 2 times 2, 6 of them, right? 2 times 2 is 4. 2 times 2 is 4. This one's 4, right? 4 times 4 is 16. 16 times 4 is 64, okay? But you have a calculator anyway, so I would just do it on my calculator, right? You don't need to memorize all this stuff. De Morgan's laws, I already said this, but it's true. If you negate this and statement, you switch everything. If you negate the or statement, you switch everything. Does that make sense? They want us to do it with the words now. The sky is red and today it is Thursday. They want us to say what the negation of this statement is. Could I say that it is not the case that the sky is red and today is Thursday? Yes, I could. But they want a simpler way to say it. Does that make sense? So then all I would say is the sky is not red or I wrote this, or today is not Thursday. Yep. Like that. There's something like that. There's something like that. I don't make the questions, honestly. There's frost on the pumpkin, or it is not summer. What should this be? That's correct. This one needs to change to and. This not goes away, and then this one we need to put a not here. Does that make sense? What about the last one? It is not April, or there is ice. Any question? You see why I like these laws, though, right? These are your friends. All right. It's called De Morgan's law. DE, and then capital M. That's the guy's name, De Morgan. A conditional statement uses the if-then connective and is symbolized by P implies Q, where P is called the antecedent and Q is called the consequent. All right. So if I say you condition something on something, what does ANTES mean in Spanish? Antes? What does it mean? You can't say antes means antes, but the means before, right? Does that make sense? What does ante mean when you play poker? Like before you start playing the game, everybody has to pay what they call the ante. And then like let's say we're all playing and you put $5 in, he puts $5 in, and we all put $5 in, right? Then they're gonna keep betting afterwards and doing stuff, but at least there's $5 sitting there on the table from each person. That's called the ante or the buy-in or something like that. Anyway, the point is ante is before the game starts again. Does that make sense? All right, because this is Latin, right? So so when they say antecedent is the beginning part, right? So it's like if I say conditional means if something is true, then something else. Okay, so based on certain condition, based on whatever the antecedent is. Does that make sense? We can try and prove the consequent. Does that make sense? All right. Sorry? I used to. Oh yeah.
Or, I mean,
I almost dropped out of school. Let's just say that.
For real, it was that serious?
All right, I'll tell you a story when we do the other chapter. I got some kids in my dorm. I was broke when I went to school, like Brizzo. And my there was this kid who came, it was like Sunday morning, like 2, 3 o'clock in the morning. Some kid rolls in, drunk as shit, into my dorm, like stunk. He was so drunk. And slurring and all this stuff. And like he comes in and like, I don't even have money to drink. I'm like, I don't know what you're doing, like blowing all this money on whatever this crap is. But he's like, his parents were rich. And his dad used to be the doctor for the heat. So you go and walk into his dorm room, and he's got pictures of him as a kid cleaning the floor during the game, playoff games, and Shaquille O'Neal and Dwayne Wade just sitting there with him, taking pictures, like over and over and over again. His dad worked there, so of course so he got to be the bald boy. So anyway, and he was in this rich boy frat at the school also. So I was honestly pretty jealous of this guy because I was like, I don't got enough money for Subway, and the he was doing all this stuff. And I remember though, like I remember I used to buy pizza there because it was buy one, get one free. And I'd buy these $20 pies. And they were huge. They were like 20 inches or something like that. I'd buy these $20 pies just because it was buy one, get one free. And I would eat the damn thing for like a week and a half. And that was all I would eat. But but then Richie Rich over here, he was doing all kinds of crazy stuff. So he walks into the dorm one day drunk as shit. And I was like, yo, what are you doing? Like, how are you going to go to school tomorrow? Like, what's going on? He's like, I just made so much money, I don't even care. I'm like, you just made money and you this drunk? I'm like, you're lucky you can stand, boy. So then he's like, yeah. I was like, how? He's like, gambling. I'm like, don't even start with me. I'm like, I know math and all this stuff. And I was like, I would work you if I was gambling against you. Like, you don't even know how to play. How the heck are you going to do this? Right? He's like, oh, somebody told me a couple of things and I started doing what they said. Anyway, I'll go into the story more another time, but I figured out what the guy was saying. And I came up with all these things to gamble. And I came up with this whole plan and all this stuff. And then I made all the kids in my dorm test it on the internet. Because this is when all these online casinos started. And then they tested it and tested it and tested it. And I made them test it on a website where the website said that if you get 10,000 on the website, we'll give you real money. So you can start with fake money and just keep gambling. If you get all the way up to $10,000, now all of a sudden they'll give you real money. So I tricked all of them into doing it. They all started doing it. They all started winning. My stupid thing worked. Okay. And then I was like, all right, let's see. Right. So then he used to go on these sun cruise things, which was this cruise that goes off the shore into international waters and then allows you to gamble. Now, I don't know. Now you probably can do it anywhere. But back then he wasn't allowed. So you have to drive to international waters or whatever. So they would float over international waters and start gambling. That's where some drunk guy taught him how to do this thing. And the guy was actually saying something good, surprisingly, So then I didn't have any money, but I wrote up this whole thing and we started asking everybody in the dorm for money. So there was 80 kids on my floor, start asking everybody for money. Got $44,000 from the people. No, got $26,000, excuse me. Got $26,000 from all these people. Went and gambled on the boat. Came back with 44 grand. And I took 5,000 because I was like, it's my idea, even though I had no money. And then Richie Rich took like a bunch, even though he didn't do anything. And then we took the rest of it and we split it up amongst all the people that gave us money. And then I turned around and I was like, Dad, that's it. That was the end of college. I'm done with college. I'm going to Vegas. And my dad turned around to me and said to me, do it. Get it out of your system. And then I was like, what did you just say? I'm serious. I'm going to drop out of school. He's like, do it. So then I start researching all this stuff, found places in Vegas to go to, found tables that I was going to use. By the way, effectively, the entire trick behind the entire thing is just to literally sit there and be like, oh, if you bet $1 right now and you lose, then you just bet $2 next time. And if you bet $2 next time, then when you win the $2, you're gonna make your money back from before. Then if I bet $4 the time after that, if I've lost $1 and I've lost $2, then I'm gonna get $4. I would have made back my $3 that I've lost. So anyway, it was based off this idea, and that's all. All right. But there's more to it, but not much. So the turns out that this is the way casinos set up the games in the casinos. So casinos sit there and they decide, they're like, oh, the table here has a minimum of $5 and a maximum of $100. They know you're going to do this. They know this is the way it works. And they literally set it up and they assume that people that are going there are not going to sit there and just try and make a little bit of money each time. And then by the end of the day, make a bunch of money. Everybody comes in there drunk and doing all kinds of stuff and blah, 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 blah. But that's what these professional gamblers do. So I got all this money and was like, oh, I'm going to go there and do it. No, then I realized that if you go to Vegas and do this, I called them and asked them, what can you do to me? What's going to happen? How long can I sit there and get? Because if you stop me in the middle, I lose all my money, everything. I have to be able to finish. You know what I mean? Because I just have to wait until I win. Once I win, I just reset my strategy. Once I win, I just reset the strategy. You just keep doing it over and over and over and over and over again. So I asked them, I'm like, what happens if I start doing this in the casino? They're like, if we realize, then we'll throw you out. I was like, all right, well, that's not such a big deal. You throw me out, I'll just go to the next casino. Who the hell cares, right? They're like, no, we'll put you on a list. And then the only place you can do is you can go to Atlantic City. You can't go to Vegas anymore. And then I was like, oh, okay, maybe that'll work. So I was just like, I started calling Atlantic City, figure out what they'll do, right? They straight up told me on the phone that they're going to break my knees. They straight up said it. They said, you're not going to walk out of here. That's what they told me. And I was like, all right, I'll go back to engineering school. So then I just started hosing my friends all the time. Like everybody used to ask me to play poker all the time. I used to just kill them. And then I went to Seminole here. I won a bunch of money at Seminole a few times, but honestly, it gets so depressing sitting there with these people. They're all drug addicts. I'll work you. I know all the probabilities.
What's our engineering?
Materials engineering. But no, I just calculate too quickly, so that's the problem.
Okay.
And then people can start getting intimidated. I'm just telling you. Because I also like I play extremely aggressively. So because if I lose at the beginning, so what? I'll just buy more because I know in the long run I'm gonna beat the person anyway. So then but like you know, it's World Series of Poker. You ever seen it? And they give you the outs.
Yeah.
They tell you the percentages.
Yeah.
Like I know all of them, and it's not that hard to figure it out. I can explain to you how to figure it out also, because all you have to do is count the number of outs you have. Anyway, whatever. I can show you how to do blackjack. I'll teach you how to do blackjack. So the if anybody, so you should never play any type of game with people you know. First of all, you're stealing money from those people. They're your friends. Why are you stealing money from your friends? Second of all, there's ways to cheat. So like in the casino, you're supposed to play with 8 decks so that people can't cheat. You play with 8 decks, I can't do much, honestly. I can't do much. But you play with 6, actually you play with 5. So it's you know, it's just who you take advantage of. I don't mind taking advantage of casino, but I do mind taking advantage of my friends. And that's honestly why I used to turn around all the time. I'd be like, I don't want to play. But then they beg you. They beg you to play. I would just give it back to them. Because all I do is I'll just keep letting the person double down. The only thing is the problem is sometimes somebody doubles out 4 or 5 times and lose every time. It's a little hectic. All right.
Is that the strategy?
No, that's a strategy. It's called progressive gambling. I have to explain it better to you. I'll explain later. That's just the simplest way to think about it.
You ever shot dice?
Yeah. Craps.
Can I ever shoot guys?
Craps was a game I bet on. I didn't bet on poker. I got a trick with craps. Anyway, so yeah, you can also, my uncle is some Jew from New York. He, the only thing I know, about my uncle really was they threw him off the roof, playing craps on the top of the roof. He didn't pay. He lived and stuff. I met him and stuff like that, you know what I mean? But his nose was messed up. But yeah, he threw him off the roof. All right, anyway, conditional statement uses the if then connective and is symbolized by P implies Q, where P is the antecedent and Q is complement. We write the statement using the if then connective. No, this is kind of stupid. All right, let's look here. Let P represent I study and Q represent the stove is hot. Write the compound statement in symbols. All right, so I study is P. This is an if then, therefore Q is the stove is hot. This is if P then Q. Does that make sense? If the stove is not hot, so then this would be not Q. If not Q, then P is correct. Does that make sense? Does that make sense? If the stove is hot,
If Q, then no.
by the way, also, that same math to do those things is the same crap they made me do when I was in the bank. Because it's the exact same thing.
You were accounting, right?
No, hell no.
I
I hate accounting so much. I hate accounting.
Was accounting?
No, I mean, I worked in finance, but I'm just joking. I mean, I had to do accounting also. I just hate accounting. So let P represent I study, let Q represent I get an A, let R represent I eat bananas. Write the compound statement in words. I eat bananas, and if I get an A, then I do not study. So this is I eat bananas, R, right? So this is and. Implies though, right? Does that make sense? Because like the and is connecting this and that. Does that make sense? All right, so if I study, so P implies then this is going to be I eat bananas and I get an A. This one says P implies R and Q. Now, I mentioned this earlier. By just the movement of a comma, we've completely changed the entire meaning of the sentence. Does that make sense?
If I study, there's this whole separate.
Right, exactly. But I mean, you know how hard that is to understand if someone says that in words? Because the difference is if I study, then I eat bananas and I get an A. If I study, then I eat bananas and I get an A. That's like the only way they can distinguish it is pausing. Does that make sense what I'm saying? Like it's very hard to hear. And honestly, it's very hard to read. Does that make sense? Question? Stating which one? Because they want you to understand that this part is one statement here. It's not as clear. That's hard to distinguish which one it is then. No, because you can't tell which one's which then. You move the comma, I can't tell which one's which. It means something else, honestly.
You can
Distinguish, yes, you're right.
One thing going around. You can
Distinguish.
You can't distinguish. You can't dis.
You can.
You cannot distinguish. You can't distinguish
There you go.
the
The difference between them. Right. Yep. All right, so construct a truth table for the conditional. All right, this one is a little strange. I am not gonna say, I will say that if I don't explain this, like there are two cases in here where people will constantly get confused. All right, so please pay attention to this thing a little bit here. All right, the rest of it, I know you know what and or and not means, stuff like that. This one is a little bit different. All right. All right, so now this says, let's go back to my other notes. I don't want to write this again. All right. So conditional statement means if then. All right, I'm considering the first statement P to be it rains today and the second statement Q to be I go to school. All right. This is the truth table for the conditional. All right, if the first one's true and the second one's true, then if true, then true. Yeah, that's true. Does that make sense?
Yeah.
Based on an initial true statement, if I'm concluding another true statement, yeah, the overall thing should be true. Does that make sense? All right. So if I say to you, if it rains today, then I go to school, and it actually rained and I actually went to school, yeah, it's true. Does that make sense? Okay. Next one will also make sense. All right. It's the last two. All right. So then the next one. True implies false is false. Okay. All right. So if I say to you, if it rains today, then I go to school, and it actually rained today, but I didn't go to school. But I say to you, if it rains today, then I go to school. It's false. Does that make sense? Based on the condition that it's going to rain today, but it rained today, right? I claim that I'm going to go to school, but I didn't go to school. All right. Well, then you're obviously lying. Does that make sense? It's a false statement. All right. So those two are easy. True implies true is true. True implies false. Or if true, then false is false. Those two are clear. Does that make sense? These next two people get confused with. It turns out that if you base a conditional statement on an antecedent that is actually false, in other words, the original first statement is false, but I say if that statement, then no matter what I'm saying after that is true. Okay, so let's so in other words, false implies true is true, false implies false is also true. I don't know why I'm writing this out again. It says it right here. All right. False implies true is true. False implies false is true. I refer to this as vacuous truth. Okay. They call it vacuous truth. Vacuous sort of means like empty. All right. All right. Let's try and see why we can say this is true. Okay. All right. So I make this statement. If it rains today, then I go to school. You understand? Okay. That's my statement. If it rains today, then I'm gonna go to school. Okay. Try to think about if this was like roads that I'm going to. Okay. You can either go down the rains today road, or you can not. You can go down when it doesn't rain. Is that correct? Those are what you're supposed to do, right? Right. But I say to you, if it rains today, then I'm going to go to school. Now I want to understand what's going to happen when P is false. Right? In other words, it didn't rain today. But I said to you, if it rains today, I'm going to go to school.
And they rain there, so you're not going to school.
Yes, sir. I ask for school every day. No, sir. Well, that type of logic is flawed. That makes sense with them? All right. So the thing is that if I say to you, I just make this statement. If it's going to rain today, then I'm going to go to school. Okay, so I'm telling you though, when it rains today, I'm going to go to school. What am I telling you about what's going to happen when it doesn't rain? I'm not telling you a damn thing. That makes sense with me? I'm saying to you. No, that's not correct. You're not saying that. So if I say to you, if it rains today, then I'm gonna go to school, okay?
What am I saying with that statement about what happens when it doesn't rain? Nothing. I am only telling you what's going to happen when it's going to rain. When it rains, I'm gonna go to school, right? And I get what you guys are both saying. Yeah, I get exactly what you're both saying. That's what they want you to think about. But I understand what you're saying. You're thinking, oh, it's gonna be, I'm saying he's gonna go to school, so therefore, if you did go to school, it must not rain or something like that. I mean, I actually think of it. Okay, so well, actually, that one I can, but anyway, we'll talk about it. So the thing is though, these two statements here are the ones that are going down the other road, right? The not raining today road. Does that make sense? Well, when I made my initial statement, I said, if it rains today, then I'm gonna go to school. I never told you what's gonna happen
It's
when
not
it doesn't rain.
raining.
Does that make sense? Does that make sense? So my point is that once the initial thing is false, then I'm basing everything off of, right? Anything after that is. Does that make sense? Right? If I wear green shoes today, everybody gets an A. My statement's true. I didn't wear green shoes. If I wear green shoes today, everybody does not get an A. That statement's true also. Does that make sense? But I'm not actually wearing green shoes.
Like,
You understand what I'm
it
That's not true.
was-
So
it was just joke.
so
I'm joking.
but this thing here, all right, false implies anything. It's true. Does that make sense? That's all you really have to remember. Right? The beginning part's false, then it's gonna be true. But they call it vacuous truth, because the thing is you're basing it off of a condition that's not actually true. All right? Do you understand, guys? So, in other words, the conditional is only false when it's true implies false. Does everybody see that? Every other case, it's true. Okay? All right, so true implies true is true. True implies false is false, and then the other ones are just true always. Does that make sense? Tell whether the following conditional statement is true or false. 6 squared does not equal 49. Is that true or false? That's true. True implies 1 plus 1 is 2. So we got true. Does that make sense? Any question? But again, this is all it is. Once you understand this, that's it. That's what it means. Does that make sense? Find the truth value of the following statement. Assume that P is false, Q is true, and R is false. Yeah, whatever. All right, R is false. Therefore, not R is. P is false. What is this? False. That's the only one that's false. True implies false. Does that make sense? If my name is Derek, then the school's gonna blow up. You shouldn't be laughing. No, but no, but my statement's obviously false. Does that make sense what I'm saying? Right? And we forgot a little arrow here, it seems. All right, so not P is what? True. Not Q is, therefore, false. Does that make sense? Any question? R is false. What's Q and P equal to? False is correct. What's false implies false? Because the beginning is false. If the beginning is false, it's always true. Does that make sense? Any questions so far?
It's kind of like,
No, don't think of this one. This is a different thing. Just memorize just this, just for this case. Does that make sense? What I'm saying? Just whatever this is, that's what it means every time. And then just refer back to this. All right. All right. R and not P. R is false. Therefore, this is false. Q implies P. Q is true.
P is false, therefore this is false. Not false is true. So this is true, this is false, or implies P is false, therefore this is true. Again, implies false, therefore it's false. R and not P. R is false. So this is false, right? Q implies P. Q is true, P is false. True implies false is false. Not false is true. False or true is true. Does that make sense? P is false, therefore it's false. True implies false. I want you to write it out yourself is my point. It doesn't matter if I can do it. This thing, almost the same thing as before, but now instead of applying just those rules we saw previously, we have to apply the conditional or implies rules also. All right, you help me here first. What do I write here? What do I write here? True first. Whichever way. True, false, false. That's correct. What's not P? False, false, true, true. Make sure you're able to write this out though, okay? I'm telling you, see a bunch of you guys not writing it down? You asking for it. You'll see. Not from me, you do well on the test, I don't care, but I'm just telling you, people start having issues when they don't write it down. Not Q is what? Oh, right. Not P implies not Q. Okay, well then we gotta go from here to here, from here to here, from here to here, from here to here. Now, the only thing is that you haven't seen symbols previously where it mattered which direction we're going. This one matters. Does that make sense?
Oh, yeah.
This one matters what's first and what's second.
Yeah, I'm
Does that
with
make
you.
sense?
I'm with you.
All right, so what's not P implies not Q? What's the first one? True. False implies anything is true. Therefore, this has to be true and this one has to be true. Does that make sense?
Mhm.
What about this one? False. That's the only way this thing could be false. What about this one? Everything's true, so it's got to be true. Does that make sense? Question? And yeah, I like say these dumb things in my head over and over and over again, but it does make you remember. Does that make sense? Not P and Q? True, false. Because it says and. This one and this one. Does that make sense? You understand? False. Next one? False. Does it make sense? False and false, right? What about the next one? True and true. Last one? True and false is false. You are correct.
Yeah, oh, I know, right?
And. It's and. All right. And I'm posting all these videos online for you. Not P implies not Q. Implies P and not Q. What'd they do? Something's wrong here. Oh, this should be not P here. They forgot to write it. There should be parentheses here also. Otherwise, it's not the same thing. All right. What's this one? False is correct. Because it's this one implies this one. Is that right? What's the next one? Same thing. True implies false.
Yeah, oh,
What's the next one?
True.
False implies anything is true. What's the last one? False. Does that make sense?
Yeah.
Use a truth table to determine whether the following statements are equivalent. P implies Q and not Q implies not P. All right, we gotta talk about this first. But I'm gonna post the whole video online for you. It's already, the last one's there for you, okay? All right, this thing. All right, there's some relationships here that they want you to understand. All right, there's something called conditional, converse, inverse, and contrapositive, okay? Conditional just means P implies Q. Converse means you reverse them. Does that make sense? Q implies P. Inverse means you negate both of them. Does that make sense? So that's not P, implies not Q. Does everybody see that? Contrapositive means you switch and negate both of them. So in other words, that becomes not Q, implies not P. All right, I'm going to read these sentences here based off of these things. And this is what we were just talking about 2 seconds ago when you were saying, like, I said, if it rains today, then I'm going to go to school. And you said, like, oh, okay, if it didn't rain today, then you're not going to go to school. That's not true. If you say to me, if you went to school, then it must have not rained today, or it must have rained today. That's not true either. All right. So we'll see why in a second. Okay. Question? And negates both of them. Yep. Just switch and negate. All right. It says it right here at the top. Switch and negate. Okay. Also, I've written out the symbols there. All right. Also, don't forget also, all of this is in your book. All right. Nothing I'm saying here is special. Does that understand what I'm saying? The book, you get it for free online. All you have to do is click ebook. That's it. You don't have to buy the book separately.
I don't know the book because
That's up to you, but I'm just saying, you don't have to buy the book for sure. All right. So this, if it rains, then we go to school. All right. Let's say that's my statement. 1 second. All right. If it rains, then we go to school. Does everybody see that? All right. So if I negate those two things, or let's say, excuse me, let's switch them first because I said converse first. If I switch them, then it's if we go to school, then it rains. Does that make sense? Those two things are not the same. All right. Because if I say to you, if it rains, then we go to school, I might go to school every day, whether it rained or didn't. Does that make sense? Sure, I told you when it's going to rain, I'm going to go, but I might also go when it doesn't rain. Does that make sense? You can't just automatically conclude if I went to school, then it automatically must have rained. Does that make sense? All right. So those first two things are not the same. Do you understand? You understand? It's like, it's English. It's English. No, English sucks. All right. Anybody who tells you otherwise, they don't know English. All right. So let's see. So wait till I give you a contract to read. Then I tell you to read it. Wait, I'm telling you, you have no idea. So like, if it doesn't rain, then we don't go to school. Can I conclude that based off my initial statement? If it rains, then we go to school. So therefore, I want to conclude if it doesn't rain, then we don't go. No, I just told you that even if I say to you, if it rains, then we go to school, I might go to school every damn day. Is that right? You cannot conclude the third statement. Does that make sense? Does that make sense? All right, let's look at the fourth statement. If we don't go to school, then it must not have rained. That shit's actually true. So if I say to you, if it rains, then we go to school, right? When we go down the rain road, we're going to go down the school road. Does that make sense? But if I didn't go to school, well, I just told you if it was raining, I'm going to go to school, right? That means the only time I couldn't go to school, it couldn't have been raining. Does that make sense? You either go to school or you don't go to school, right? I said to you, if I go to school, excuse me, I said if it's raining, then I'm going to go to school, right? Right? Okay, fine. I can go this way also, but I'm telling you, we go in this way. Does that make sense? If I'm telling the truth, then when it rains, I'm going to school. Is that right? Okay. Now, I want to know what happens
sort of, what can I say if I didn't go to school? Okay?
Mhm.
Okay. Well, I just told you, if it rained, I'm going to school, so I can't go this way. Does that make sense?
Back out.
The only way I could end up not going to school
Just go down.
had to have not been raining.
And it will not rain.
Does that make sense?
But then-
So the thing is that,
You just said that, you said we have.
no, it's the other way. I said that if we go to school, then it rains. If it doesn't rain, then we don't go to school. Those two statements are not necessarily true. Because if it doesn't rain, I'm not 100% sure that this person's not gonna go to school. But if they didn't go to school, it couldn't have been raining. Because I just told you if it rains, I'm gonna go. All right, so but anyway, if you haven't noticed, English sucks, okay? And the whole point is you don't want to do it this way. And that's why they're writing out these symbols, and the symbols are actually going to be much simpler. All right. So the thing is statements 1 and 4 are actually completely equivalent to each other. The conditional and the contrapositive are the same thing. Okay. The converse and the inverse are also the same thing. All right. But the contrapositive is not the same thing as the converse. Does that make sense? So the bold statements there are the same. The italic statements there are the same. The bold and the italics are not the same. You understand? All right. In terms of symbols, the first one just P implies Q. The next one's Q implies P. The next one's not P implies not Q. The next one's not Q implies not P. Does that make sense? All right, let's look at the truth table. So P, Q, not P, not Q, P implies Q, Q implies P, not P implies not Q implies not P. All right, I just wrote all these out here. Not P is going to be what? False, false, true, true. Not Q is going to be false, true, false, true. All right. P implies Q. This is the regular old statement from the beginning. True implies true is true. True implies false is false. False implies anything is true. Does everybody see that? Now, if I try and do this one, not Q implies not P. Now I have to go this way. Not Q implies not P. Does everybody see that? False implies anything is true. True implies false is false. False implies anything is true. True implies true is true. Both of these actually end up having the same value in all cases. Does everybody see that? I strongly, strongly suggest you write this out by yourself. Does everybody understand what I'm saying? All right, as an exercise. It's on your homework anyway, but does that make sense? All right. But you see what I'm saying? Like you say these statements fast, everybody thinks all of them are the same thing, right? Right? They all sound the same. Does that make sense? All right. So then Q implies P. Also, I'm telling you, all of it's in your book. I'm going to post a video online for you. I don't mind if you take videos and stuff like that. But I find people that do end up failing because they don't study. They don't look at it later. All right. If you're telling me that you think it's a better idea, take a snapshot of my crappy ass handwriting than the whole book, because the book explains it to you and there's videos there for you. I think you're choosing to study inefficiently. Does that make sense? I'm not saying you shouldn't do it if you think it's going to help you, but I think there's better ways to help yourself. Does that make sense? All right. So the try and always go back to the book. I know it's not what you want to do, but I'm telling you, first of all, you're paying for it. You might as well use it, right? But it's better that way, right? But I don't mind. You know, you can do it, but I'm just telling you, as a teacher, I see people mess up when they start doing that sometimes. All right. Q implies P. Now I have to go this way here. So this is true implies true is true. False implies true is true. True implies false is false. False implies false is true. Now this is not the same as this one here. Does everybody see that? Does everybody see that? The gray one and this yellow one here. Does everybody see that? Right? They're like not the same here and not the same there. Is that right? Not P implies not Q. So now from here to there, false implies false is true. False implies true is true. False is the beginning, it's automatically true. True implies false is false. True implies true is true. Again, this is not the same as this yellow one, but it happens to be the exact same thing as this one. So the inverse and converse are actually completely equivalent to each other, always. But the contrapositive, the one where you switch both of them and negate both of them, that's equivalent to the original statement. Does that make sense? Does that make sense? And that's really the main thing to remember, just that the contrapositive is the one that ends up being the same. Does that make sense? If you remember it that way, it's pretty easy. The other stuff's not the same. Does that make sense? Question? And when you get confused, and after you've done this before, hopefully you write this out a little bit, you'll be able to write it out again pretty quickly. You'll be surprised. All right. And that's all we end up asking on these homework assignments. So you'll be pretty good at that. Question with this? All right. So that's what I just did here. Oh, so we're almost done. All right. This garbage. I hate this stuff. Oh, look at that. I already did it. All right, now what they want to do is they want to find the equivalent statement for P implies Q, but not using imply. Does that make sense? Using and in orders. Turns out you can do that. All right. Let's first explain with this picture, and then hopefully this will make a little sense. This is the first time now I'm going to be using the fact that there's a relationship between the sets and the line. You do it both ways. This is the way I generally do it. P implies Q. Right? So let's try and remember what this is first. All right, got it, right? I need to think of a statement that's going to be equivalent to this thing. I'm using the and in order. Know what I'm using it, not using it implies. Know what I'm All right, let's try and again label the regions that are over here. So we can start correlating which things are true to this diagram. I'm gonna label this region as 1, this one is 2, this one is 3, and this one here is 4. 1 is where they're both false. That's this last bit. This is P is true and Q is false. That's that one. This one is both true. That's that one. This one, Q is true, P is false. Understand? Any questions over? Okay, so where is this true? 3, 4, 1, 3. And then this guy. Those regions. Understand? Question on this so far? What is this? Well, it's not P. Is that right? That looks like almost not P. Is that right? It would be not P if that 3 wasn't true. So it's not P or it's Q. Does that make sense? In terms of sets. Not P or Q. Does that make sense? That is not P. All right. Question about that?
They're equivalent. Not P would be what, false, false. True, true. Not P or Q, this or this, true, this or this, false, this or this, true. True. They're the same. Understand? Understand? And you just memorize this. P implies Q, it's the exact same thing. Not P or Q. You get your first part of the second part, one change to four. Understand? Alternatively, sometimes they want you to remember this also, not this, and would be not over there, understand? Just do not on both sides, understand? And you get this, you would get P and not Q. They want us to know that, understand? Understand?
All right. How did this get here? This was here the whole time and I just didn't pay attention. Whatever. All right. Write an equivalent statement which does not use the if then connective. So now I want to take this statement, stop using if then in it, using this stuff here. How would I do that? If he oversleeps, then he misses the meeting. How would I rewrite that? Did you get it? No, they want you to write it without if then. That's correct. If, not if. He, just he, right, that's correct. No, he doesn't oversleep. Or he misses the meeting.
I don't know why I don't like reading. Reading is so fun.
Oh yeah, you can read those two sentences and realize they're the same thing.
Reading English like definitions.
I'm just telling you though, those two statements, those are English, right?
Wow.
But no, but those two statements right there.
I don't know how to be it.
I don't know. Yeah, okay, so you want to make some poems. So the all right, you guys got this though? All right, what's this next one?
I'm telling
So
you.
then this, I want to do the same thing. Now that means all you have to do is negate the first part, change it to an or. Is that right? So you
Let's do it now, man.
making my ass hungry. Oh, I hate turkey and I even want turkey right now. All right, so then the turkey's such garbage. All right, so the this
So even when
Thanksgiving was the first Thanksgiving in my house. I decided finally no more turkey. I made ribs.
I had rabbit.
It was way better. Everybody was so happy. Everybody's like, fuck turkey. All right, so you write the negation of the following statement. If the ball bounces, then the ball is orange. All right, so now you have to change it to an and. So let me just write it out for you again. So P implies Q is the same thing as I just said, not P or Q, right? P implies Q, not that, is the same thing as negating all this, which means then it's going to be P and not Q. So we have to write P and not Q now. Does that make sense? Go ahead.
The ball bounces. The ball is on. And the ball is on.
Not orange.
And the ball.
It's not orange. This one has a not.
Oh, that's enough.
Yeah. But otherwise you're correct. The ball bounces and it ain't orange. Does it make sense, guys? Question? The ball is not orange. Wait, what did you say? Say, if? No, they just said don't write if then.
We need to be doing the opposite.
Yeah, they don't want you to with me. They don't want if then.
They
You
want the
gotta-
opposite of whatever they give you.
Yeah, they want you to write this without doing if then.
Okay.
All right. The directions here aren't the greatest, but that's what they want. Does that make sense? If he oversleeps, then he misses the meeting.
He did not oversleep.
No, this one says, because they want negation, right? So this, he oversleeps and he does not miss the meeting.
You see math? You see math?
Looks like English to me, boy.
No, it is just math. Math is.
Looks like English. So the, if Hannah is 3, then Morgan is not 10. This is the woman who wrote this. These are her kids' names. So if Hannah is 3, so what would it be?
Hannah is 3. Morgan is younger than 10.
And you gotta remember, and Morgan is 10 is correct.
Oh, so we're doing the opposite, right?
But for that one, yeah. All right, that is all. We're done now, okay?
That's how I'm gonna- Oh, I need to.
We have a lot of classes before this. You know,